taken back BDD, or Behaviour Driven Development. So, not many people know that BDD started with two very simple premises. BDD started as a collaboration and design tool. And somewhere down the road, it completely derailed, and people started again, same as with test-driven development, focusing too much on this word test, and not enough on collaboration or design. And BDD community in general in the last years trying to put it back on the rails by focusing back, bringing focus back on communication and collaboration. And we're doing a decent job, but there's still a long road ahead of us. That said, what we completely miss is that BDD is not only about collaboration, it also has a big part of it, which is about software design. And this talk is me basically trying to get it back to the beginning, where it started, and looking at BDD as a design tool, as a tool that could help you to see and make sense out of the software design, and basically give you some indication or directions that you can, with addition of your own design skills, coin and drive as part of your system design. So behavior-driven development, what is it? I wouldn't go into details, but in a very, very simple way, at the very high level of abstraction, BDD is when you take a user story like this one, in order to spend more time socializing and less time choosing tracks. As a conference attendee, I would love to arrange my personal schedule beforehand, right? It irritates us all to choose talks before each like hour, and it would be awesome if we could just like create our own personal schedule where you could choose tracks before the day, and then you socialize with people, and this like the app just tells you where you need to go next. So BDD is when you take this normal agile user story and you just ask, okay, can you give me an example, right? Can you give me an example of how it would work? Can you give me an example of how you, user or stakeholder, will use this tool, right? And it usually results in back and forth conversation where we're throwing examples at each other and end up writing them down as something like this, right? We have two scenarios, two very simplistic edge cases. One is successfully choosing one talk from a time period. So given there is a conference, SwanseaCon, and there is a taken back BDD talk in the first time period, when I choose this talk, then this talk should be my personal schedule, right? And then we're also saying that if you try to choose two talks from the same time period, you can't attend two things at the same time, even though Sandra probably will try. Now, this is where most BDD practitioners will stop, and I wouldn't blame them. This is where I would stop a year and a half ago. And that's a good enough list of examples to drive your implementation from, right? That's a good list of examples to actually verify the behavior of your underlying system and drive the behavior or implementation of it. Now, but I would, for the rest of this talk, argue, what if we don't stop? What if we push forward and start asking for more details, start extracting more information from a stakeholder? What if instead of just stopping here, we start asking what all this means? So, given there is a conference, SwanseaCon, so there is this text, SwanseaCon, and there is a conference. What's the relationship between two? Then I also see we're mentioning this first time period or second time period. What is a time period, right? Can you give me an example of time period? How would it look like? And then there is this personal schedule which is not connected with things. So there's a lot of details that are very, very hidden here. And you would usually go for these details inside the iteration. What if you ask straight away when you're talking about examples, how do you actually call this thing? How do you, as a stakeholder, call that particular bit of your example? Do you actually call it like a conference string? Do you call it a time period, or is it something else? How is personal schedule connected with your conference? If you push hard enough, you would end up with something like this, which is much more verbose, but has very important information in it. Given the conference named SwanseaCon 2015 with one track, so not only we see that this string, SwanseaCon, this text, is a name of the conference indeed, right? And that's what defines the name of the conference. We also see that the conference has a number of tracks associated with it. And we also see that this time periods thing that we had before is actually called time slot. And the time slot is nothing else than just like a range of time. In our case, from 16:30 to 5 p.m., all right? And all those details, this is not implementation detail, this is not your design, this is not your architecture or entities. You're talking with stakeholders that had no idea about this. What it is business knowledge. It's an understanding of the underlying business that stakeholders have in their heads. What we're trying to do here is we're trying to extract this information from them. And this information has a very specific name. It's called ubiquitous language. Now, why is the ubiquitous language important? Ubiquitous language was coined by Eric Evans, creator of domain-driven design, and he puts it this way in the Blue Book or domain-driven design book. A project faces serious problems when its language is fractured. Domain experts use their jargon, while the technical team members use their own. So why is it a problem? Well, let me show you a very simplistic example of how the software in my head is developed from the human collaboration perspective. So it usually starts with some guy, some business person, that has an amazing business idea that he needs to implement in life, right? And he usually can't do this himself because he's not an engineer, so he communicates this idea to an engineer. An engineer interprets this idea in his head into some set of instructions or abstractions that he then communicates to the machine, and machine then interprets it into the set of bits and bobs, right? Now, the challenge with this approach is that imagine a situation where business asks for something very specific, but at the same time very vague. Business says, in the next iteration, I want us to implement accounts, right? Customer accounts. And then when he says customer accounts, what he might think is he might think credit accounts or debit accounts because they're built in banking system. Whereas when engineer hears accounts, because of all the aggregated experience engineer had, engineer might think user accounts with password recovery, user management, rule management, and all this kind of stuff, right? The problem is, engineer then goes back to computer, spends some time, writes this code, spends weeks, goes back to the business, and business is obviously unhappy because what business gets is a user management system. What business needed is a credit account or debit account management system. So this situation where two parties use the same language, express in the same natural words, but imply different meaning is called translation. And translation has cost. In software, translation cost is usually calculated in the amount of weeks of overwork. When you're going in the wrong direction, trying to build something that business doesn't need, and not build something that business actually does need. And before Agile, that was years. And that, like, one miscommunication like that could basically kill the project altogether. Now, with Agile, we kind of fixed it, but we didn't. We actually shortened the time loop. Now it takes weeks instead of year, but it's still weeks doing the wrong thing. Now, we know this problem because that's what BDD solves. Behavior Driven Development tries to solve this translation cost between business and engineers by introducing this very simple feedback loop. What happens is, whenever your business says, I want accounts, you don't just go and try to implement them as an engineer. What you do is you start asking, okay, I got it. Can you give me an example? And business straight away gives you an example about some woman called Lucy that uses the system to create a credit account. And then the engineer immediately understands, oh, it's not about user management. It's actually about credit accounts. Got it. Can you give me another example? In which case it will fall back. And that communication and examples helps you to avoid this working for weeks on the wrong thing. That essentially eliminates translation cost. But now, in order to eliminate translation cost, you need two parties to talk exactly in the same language. It wouldn't help if your engineers keep talking about high-level abstractions or low-level abstractions, and business talks about the business. But just because both parties are human beings, we solve this problem by just forcing engineers to talk in the business language. That's how we, in a legacy fashion, do this in BDD, right? We're saying, engineers, you need to learn how to talk with business in their own language. And that solves the problem. Business becomes happy because every iteration engineers deliver exactly what business needs, right? And engineers are happy because business asks them, clarifies exactly what they need, and it takes just like days to implement this new functionality, and it just like this cycle goes on and on and on. But at some point, something weird starts happening. Some addition or change that was taken just days before, or could have taken days or months before, now suddenly takes weeks. And that makes engineer very unhappy. And the reason why this happens is even though those two parties, business and engineers, talk in the same language, they do know what they mean, as soon as this conversation stops, engineer goes back to computer and starts writing code. And that code has no relation to the business whatsoever. It's just a set of abstract instructions. And at some point, this code that he writes and the business conversation he has gets so disaligned that the small change in the business can take months or weeks to implement in the code. And sometimes the change is so expensive that it's worth just to rewrite the entire system. So you still have a translation. But it's not a translation between business and an engineer, it's a translation between business and the computer and the code that you have. They are not aligned. Whatever you write into your code base has no connection with the business that this code base is supposed to serve. But, as with BDD, we know about this problem. We know about this problem for quite some time because this is exactly the problem that domain-driven design is supposed to solve. And how does it solve it? Well, it introduces the feedback loop. So whenever engineers try to come up with some abstraction in the code base, they communicate back to the business this abstraction, not in the programming language terms, but in the words terms. They say, okay, so we're doing it this, and we're creating this business rule that applies in this regard, and it works like this. Does it make sense for you as a business? And business says, yes, it completely does make sense. Or business says, no, what you're saying is complete gibberish, and what you need is actually this operation doing this thing. Which again is not a programming language, but a language of abstractions that human beings are naturally very good at. And naturally here, you again need to introduce the same language that all three parties can talk with, and now it can't be business language anymore because computers are rubbish with business language. And it can be programming language because again, businesses are rubbish with programming language. So usually it ends up being something in between. Something called ubiquitous language. Ubiquitous language is a shared language that business and engineering team create together in order to communicate about requirements or the business rules in general. And that, hopefully, solves the communication between all parties. And now it takes, again, every time business needs some small change, the code base is so aligned with the business that this change takes not even days anymore, but hours, right? Because it does make sense, not only in the business sense, but in the code base sense. Now, this is all fine and dandy, but now you have a very interesting challenge ahead of you. You have two practices, domain-driven design and behavior-driven development. And I don't know about you, but for me, it took 4 years to deeply understand behavior-driven development, and I'm still learning. And I started learning and exploring domain-driven design 3 years ago, and I'm still learning. So those two are very heavy, very deep practices that it takes time to learn. And they're also very expensive on their own. And now what I'm saying is just like you need to use both to eliminate this arbitrary thing called translation cost. But do you need to use them both, right? Are they so different? They do operate on the different levels, and they do use different tools, but how different are those tools? And in order to look at those practices, you need to look at the tools on which they operate. So the most famous or the core tools of BDD and DDD are this. Behavior-driven development commonly uses examples. Right? Example like I showed you before. Right? Those two scenarios are two examples of how the system should behave. Right? Now, domain-driven design uses a different tool altogether. Domain-driven design uses domain models. And the usual understanding of domain models for most engineers is that it's some sort of like a doodle on the board or some graph or some set of boxes with arrows between them. And that's how we think about domain models, right? Sometimes experienced DDD practitioners also think about domain models as a code base. But now if you go back to the Eric Evans book, the way he describes domain models is that it could be anything. It could be drawing, it could be code base, it could be a word, it could be a set of sentences. It could be a set of sentences that incorporate business language and describe how this business behaves. And that will also be a valid domain model. So if we go back to our examples that use business language, that do operate on the business domain level and describe the business rules in the domain. If you go by definition in Eric Evans, that actually is a domain model. one of the domain models for this particular domain, for this particular business. So the premise of this talk is that pushing for ubiquitous language in your examples makes them a domain model. And when you make your examples a domain model, you can start using your examples in a very interesting ways, right? So you can use the same feature or same set of examples to drive both the domain model and the UI of your application when you're doing test-driven development or behavior-driven development. And that process is the process that I call modeling by example, or the way Dan North called it, BDD as it was meant to be done, or BDD as Dan North seen this being done, right? And it's basically a combination of domain-driven design and behavior-driven development into one coherent practice. In order to understand how we can mix domain-driven design and behavior-driven development, we need to see how they both operate on the higher-level design level. So if you simplify any application ever, most of them fit into this doodle. You have a user interface at top, which represents an interaction layer between user and the system. User interface then delegates some functionality or calls to the application services layer, which is high-level abstractions in your code base, representing use cases. And then those use cases delegate calls to the lower-level domain objects or small business rule objects in your system that do job in a very small fashion. So those three layers. Now, the common way to approach BDD in regards to these three layers is commonly known as outside-in. And outside-in, like in the system level. So outside-in in the system level is when you're like starting from the UI level and you go layer by layer until your scenarios or your features are passing, right? Outside-in meaning you go through UI down to the root and you don't stop until you implement everything, and when you implement everything, when your scenarios are green, it means you have UI, application service, and domain objects. Now, the problem with this approach, if you think about domain-driven design, is that domain-driven design as a practice cares about these two layers. Domain-driven design as a practice doesn't care about UI at all. And the problem with going outside in and DDD is that in order to test things you care about, you're kind of going through the thing that you don't care about. So that's why the most common way to do domain-driven design is called middle out. So with domain-driven design, you start by implementing application services and domain objects, and when you're done with them, your tests are running, then and only then, you add UI on top of that. Now, in order to do modeling by example or a combination of both practices, you need to do something different. And again, as with domain-driven design, the first step is to implement the business logic. So we don't care about UI as a first application. So we take UI out of equation, and we go outside in, but we go through domain layer, through application services layer, directly. And that step I call abstract, because you're creating an abstraction for your business rules or for your business. And when you're done with that, when you have your running scenarios or your outside in tests passing, then you add UI back, and you go again outside in, but now through UI, reusing the domain that you built in the previous step. So two steps, you abstract, and then you add interactions on top of that. Now I know it's quite vague, so that's why for the rest of the talk I will just give you an example of modeling by example of how it actually goes. And for that we will use exactly the same feature that we started with to not confuse things, right? Exactly the same one. So again, phase one, abstract. So let's create a domain model using our scenario. And again, as with anything TDD, you go step by step, in our case, scenario by scenario, right? So we start from the first scenario, we start from the first step. Now, the way most BDD tools work, or Gherkin tools work, is that they map each step in the scenario to a particular method call that represents the automation behind the sentence. It's like, automate me this sentence, and the program will just run this automation script for you to make sure that the thing works. Now, a word of caution, for the rest of the talk I will use PHP as a programming language, for example. There is two reasons for that. First of all, I want to use a language that I'm most comfortable with, and the second reason is I want to show that clumsiness of the language, and I'm quite aware of the clumsiness of PHP, does not have any implication on your domain code. And you can do very smart and beautiful things, even with the very limiting from the syntactical point of view language, like PHP. So the way BDD tools work in PHP is like this. You have a context class. Context class represents your list of step definitions. Step definitions are those small method calls that map to a particular step in your scenario. So in our case, we're starting with the first step, given a conference named with count tracks. So what we need to do here is we need to replace this pending exception with some code that represents automation of that step above. Now that would be very easy if we're going outside in, right? We just slap some UI logic on top of that to go through end to end. But we decided deliberately to not go through UI. So now the question looms, what do we put there? And the usual answer is like, okay, we drag a board inside the room and we start talking and standing next to the board and drawing the schemes and diagrams and how the boxes connect and how we call the boxes and method calls and stuff. But for the rest of the talk, I want you to just imagine that this conversation already happened. It didn't happen between you and other engineers in the team. It did happen between you and your stakeholder, your business. Your business already gave you all the abstractions you need to build the system. You just need to extract them. So what we're trying to do here is we're trying to eliminate or minimize this translation that we had before, to minimize the ongoing translation cost in the later. So we try to minimize the amount of translation happening from the language or the words or the sentences business used and the code that we will write. So what we will do here is we will take a sentence above and we'll try to transform it as close as possible to the programming language at hand. So in this case, we have a sentence saying a conference named with tracks. So a conference becomes a conference variable to which we assign a conference named with tracks. So named with tracks in this case is a static method factory, and it basically creates a new conference. So the way it reads is a conference equals conference named with tracks, which is all very, very close to given a conference named with count tracks. And as an outcome of this, we have a conference object and named with track method in it, or static factory method in it. Now the question that people ask me when I just showed this first time is, how the hell did you design that? Or well, where did this design came from? And the answer is very simple. Your conversation with your stakeholder, the conversation with the business, was your lead designer. Your conversation designed how the system works. And depending on how your business describes the problem or talks about things will lead you in the different branches or different routes of how you will design the system. So in our case, the business said, or conference organizer said, given a conference named SwanseaCon with one track. That led us to create conference with named constructor of named with tracks. Now, if instead of that, business would have said, given a conference named SwanseaCon 2015, and this conference is planned to have one track, that would have led us to create two different objects, conference and track planner. Track planner would be responsible to plan amount of tracks for a particular conference, and conference wouldn't know about tracks. So step number 2, and the taking back BDD token schedule for a particular slot on the track 1. Again, the same approach. We look at the sentence above, and we try to transform it into the code with minimal amount of transformation or translation. So talk is scheduled becomes schedule talk. Where do we schedule talk on? Well, we schedule it on the conference, right? The conference we created in the previous step. So this conference schedule talk, and we pass talk, slot, and track. So suddenly we have now additional method in the conference and 3 other value objects representing those objects that conference is connected with. And this is the point where people start asking, okay, now you have this abstraction with 3 objects there. How did you end up with them? Like, is it just like, how did this come out of the simple conversation with people that are not experienced in programming languages whatsoever? Well, the reason why it came up is something that is called natural abstractions. So we, as an engineers, are very familiar with this concept of artificial abstractions or abstractions. Artificial abstraction is when you have 2 pieces of logic and you see that they share some behavior between them, and you say, okay, it will be very useful if we share this behavior by creating an abstraction between them that those 2 guys are sharing. So like an interface or abstract class. And this is artificial abstraction. It's an abstraction you created out of necessity for simplification of the code base. Now there is another kind of abstraction, and it's an abstraction that human beings were using for thousands of years. It's a natural abstraction. And it's when we need to describe a complex concept that takes like a lot of words, a lot of sentences to describe, and we need to do this on the ongoing basis, we find an abstraction to it. So a good example for this, if you ask me, what have I eaten, or have I eaten this morning, I might, for the starters, if I don't know better, start explaining to you, yes, I had eggs, and I had sausages, and I had beans, right? But then after 10, 100, 1,000 people asking the same question and me giving the same answer, describing all the ration that I have this morning, it gets tedious, it gets boring. So what I do, I create a word that describes this. And we as human beings are really good at creating these words. So we say breakfast. I had a breakfast. So where do you think the word credit cards came from? Debit cards, debit account, credit account. It wasn't been here. We didn't start with these words. We created these words to describe a complex concept that took paragraphs or sets of sentences to describe before. And somebody got tired of repeating these sentences or paragraphs to describe these complex rules. And they said, let's call this credit accounts. So that's a natural abstraction. That's an abstraction people use to describe the complex concepts again and again and again. And the cool thing about natural abstractions is that they have a longer life period or longer lifetime than artificial abstractions. Artificial abstraction is something that you create in a code base just for the purpose of reuse or simplification. And you usually destroy abstractions in a matter of months and you replace them with better abstractions. Whereas natural abstractions, because they are part of the human language of a particular business, they tend to stick. It's very hard to replace one word, credit accounts, with something else completely. So they stick, and they stick for a long time. So it's a usual case where you join the company and you left the company, and the company still uses the same natural abstraction, whereas it might have changed 5 different artificial abstractions throughout your lifetime in this company. This next step, when I choose the talk in back BDD talk from a personal schedule of this conference. So again, no magic here. We're just replacing whatever is, we're just transforming whatever is said in the sentence as close as possible to the programming code at hand. I choose the talk, becomes choose talk, we pass a talk. Where do we choose a talk? From or for? Or we choose it for my schedule, so we create my schedule variable. What is my schedule variable? Well, my schedule variable is a personal schedule of particular conference. So it becomes personal schedule of conference, this conference. So you see, this is where like clumsiness of the language, which in our case PHP, and it forces you to use $this to reference to the instance variable, actually plays in our favor because it reads better. Personal schedule of conference, this conference, right? And suddenly we have another object that does connect with our conference, and now we have a personal schedule with 3 methods in it. Now, the question that people ask me from this point on is, what if we get it wrong? Naturally, right? So if we derive so much of the design from the conversation, what if this conversation was wrong? What if business missed something? What if we didn't ask some concept? What if the guy we're talking with is not as experienced as he should have been? And the answer is, it's totally fine to get it wrong, as long as you're looking forward to improve. So the way this works is there is a very simple cycle where you have a conversation in form of examples with the business, and you ask as much details as possible, but you will always miss things. You will always misunderstand things. That's part of the process. You automate this example, which leads you to create particular domain model in the code. And then creating this domain model will reveal some questions, some unanswered questions about your conversation, which you will then use to feed further conversations, further examples with your business, and then you will reveal those things. And that is like ongoing cycle where you learn more and more about your business, and you fit it back to both examples, you refine your examples, your scenarios, and you refine your domain model or your code base. Then the talk chosen for a particular slot of my schedule should be the talk taken back BDD talk. So this is our assertion step where we're actually testing the outgoing outcome of our interaction. So again, no magic, just repeat the thing. The talk chosen for slot, and we pass a slot, and we do this on the schedule or on our personal schedule. We assert that it equals to the particular talk, right? Very simple. And now, when we run this, first it will obviously fail because it returns null, right? So later on, we will start writing unit tests to wire these things up. So this is the step when you first get to your then. You usually have a bunch of objects interconnected between each other with a method calls, but all those methods are empty. They don't do anything. So you start writing unit tests to actually fill these objects with behavior, and you test them in isolation from each other. And through this process, you will find out that there is a missing concept here. And the missing concept is that you have a conference which link to a particular talk in track, slot, and talk nature. So conference has this linkage to three things at the same time. And this track, slot, and talk represent one thing. Whereas the personal schedule is just linked to the talk. So there is this missing interaction between two. There is a missing concept around track, slot, and talk. So what do? Well, there is a missing business concept. So you go back to the business and you ask them, okay, so you know what, when you're like saying that there is a talk scheduled for a particular slot and a track, you use those three things together to define a talk. So how do you call this talk, particular one, for the conference? And the business will say, well, we call it scheduled talk. And this is how you will reveal this missing object there, and you will write unit test, and you will derive behavior of this object. And through this process, hopefully, you will make your scenario pass, right? So this process where you're using both unit tests and higher level acceptance tests, like in our case, Gherkin tests, to drive the behavior, higher level and lower level application behavior, I call this planting object-oriented software. It's the same principle as growing object-oriented software, but I developed upon it. So the principle is, imagine you are growing a system, right? And the system is, it's a tree. So you start growing tree by just like putting a stick into the ground, and the stick is equal from the both sides. And then you want the stick to grow into a medium level tree. But now you know in order for this tree to stand or to grow to the medium level, you need a lot more roots supporting this tree. Otherwise, it just fall apart. So in this case, the roots, all those underlying things that are feeding tree, those are your small business objects in the code base, where the tree itself is like external behavior of your objects. So why do you need to use both acceptance tests and unit tests? The same way that you need to put a pressure on your tree from the atmospheric conditions, like acceptance tests, you need to put a pressure on your roots of the tree in order to make sure that they grow properly. And that's where your unit tests come, right? So developing software is much more like growing software rather than just building it. And you need to start growing it from somewhere. And for me, this process is almost like a planting a tree, where you do start with exactly the same amount of acceptance tests and unit tests, but then unit tests start growing with a much higher pace than acceptance tests do. But that hopefully leads you to a green scenario, our first green scenario. So our first case is completely covered with our business logic, and that is a time to switch to the next one. Now, I will skip all the process of me going step by step through this one, but it's suffice to say that in order to make this scenario green, you will end up adding an additional object to your domain model, which is slot has already taken exception, which is thrown by personal schedule if you try to put two talks into the same slot. And you get to the green scenario. Actually, you get to do two green scenarios. Now, why do I do that? Why do I go purely through the main object, through the main model, through application services? Why don't I implement UI? Why don't I implement infrastructure layer? And there is a very simple answer to that. Is because I want to get shorter stakeholder feedback loops. Now, can you deploy the system to the users? Well, technically you can, but they wouldn't be able to use it, right? It's not usable by anyone. It's not deliverable software. But at the same time, if you ask a slightly different question, can you start getting feedback on it from your stakeholders, from your business? You absolutely can, right? Just running this against scenario and describing how the process works, how you model things to your business and asking, does it make sense from the business perspective? Does it make sense for you as a conference organizer? You already can start getting this feedback where business can say, no, you know what, this personal schedule, the way you described it, doesn't make sense. It doesn't really link. And you will probably have problems later down the road when we'll add additional behavior to the personal schedule, right? If you implement everything all together as one big bunch, domain, persistence, and UI, just getting to this point where you can start asking for a feedback could take you days or weeks in the worst case scenarios. Whereas if you take persistence and UI outside of the box and you just say, okay, let's focus on domain first, let's make sure that the business rules work properly and are aligned with the business, you can get to this like in hours. So in 1 hour, you can actually get a feedback from your test suite go back to the business and ask, okay, so here's how it works on a very, very high level. Is it aligned with how you see the business? And business says, yes. Okay, let's add UI on top. And this is where you go to add UI. Now, UI is very important. Again, you can't deliver this thing if there's just business logic without infrastructure. But when you already have business logic and it's tested, it's green, right? You start looking at UI very differently. It stopped being this like overreaching layer on top of your entire application that needs to be there. It's one of the 3 very important bits. It stopped being this like thing on top of everything. And it starts being something like this, right? It's just a controller that you plug into your application services just to get an input from the user and give him some feedback, some vibration maybe. And you could have many controllers, right, for your application services. You could have phone controller, you could have API controller, right? But this thing is just to get and give feedback to the user. It's not as integral part of this business logic as you thought it was. And actually, that liberates you to go very expressive in your UI layer. Let's skip into this. So we have this feature again. We have our domain. And as I said, interact is like, again, going outside in using the same feature. Now, this is the point where you ask me, do we really drive every scenario through UI, right? So just to complicate this case, it's like, so imagine we have a feature with 6 scenarios. We went through them one by one, implemented all 6 of them through the main. Now you're saying that you need to go through all of them and implement them through UI? Well, no. And the reason for no is that whenever you already have a business logic implemented with all the guards put in place, with all the constraints verified, adding those feedback around these constraints has a very diminished returns, right? So it is important to give user feedback, and that's what all we do with interaction phase. Feedback on a core journeys, maybe on the core passing journey or the core failure journey where people just mistakenly enter the wrong information or try to do the wrong thing. Now, is it as important to provide a feedback to the customer that deliberately tries to enter data that nobody ever ruled? No. It's absolutely fine to throw an exception and give him 500 page if he tries to do something really crazy. Your domain will protect you in this case, but do you need to provide a clear feedback? No, you don't. So that's why you don't really need to implement every single scenario through UI, just a couple of them. And I call this scenarios critical paths, right? And the way we treat this is we just basically go through our feature and we tag scenarios that we do want to provide feedback upon as critical. So just add critical. And again, through each scenario tagged as critical, we just go one by one, step by step. Now, given steps, it usually doesn't matter how the system gets into the context where you can operate on that, even in UI context. So for the givens, you can reuse exactly the same step definitions and exactly the same steps you used before. So even though you're creating a different set of step definitions, you can reuse the ones that we used previously for the main model. You just copy-paste them. But then when you get into the when, this is where the things get interesting. Because what happens here is you need to start representing the actual user interaction with the system through UI, which is not domain anymore. So the first thing we do, we visit particular web page, which doesn't exist yet. Then we find particular element on the page, which again doesn't exist yet. And then we click on the add to my schedule link inside this element. And that will lead you to create the whole HTTP server application, spawn the web server, run through this thing, wire everything into the main model. And then at some point you will discover that, okay, everything is there, but the conferences aren't, right? So there's no conferences, there is no talk. And the reason why there is no talk is that that given step we used before, it was operating in the same process space in memory. And when we're creating this conference, it's not actually propagated to our UI, right? There is no persistence layer between them. So when we're creating the conference from UI perspective, we need to persist it somehow. Now, everyone familiar with domain-driven design, the first answer is, okay, everything is okay with the way we translated this code. It's just like there is a missing infrastructure concern. So we need to persist something. So, of course, domain-driven design, we need a repository. So we need to persist conferences, so conference repository, save conference. And that's an assumption that there is nothing wrong with the translation. We translated everything properly with the business. It's just like we missed this technical concept. Or you can step back and start thinking, what if we did translate everything properly, but what if we missed something with the business? And you go back to the business and you start asking questions, okay? Given a conference named with trucks, so you're just stating that there is a conference. How many conferences do you organize? Okay, like 20, 50. How do you keep track of them? Do you remember all of them? Right? How do you keep track of the conferences? And then the business says, well, first of all, we have this thing called planner, and we plan the conferences. Oh, you plan the conferences. Right? So now suddenly you have this missing concept, you add it back to your example, and now you have conference planner that is responsible for storing conferences on an ongoing basis. So that's why it is totally okay to get it wrong in the first place. Because writing code, writing your domain code, and having ongoing conversations will enrich both, right? And this is a case where we started writing domain model through the new layer of automation, and we'll find that there is a missing concept. We went back and had more examples with the business. We asked, okay, you missed something, or is it just us being dumb? Yeah, of course you're being dumb because there is a planning phase that you completely missed. And the last step is basically us making an assertion. So we assert that element text for like my schedule talk contains particular time. And then we go and implement this thing like through UI. So we just add the things, add the personal schedule on the end to end. The interesting example here is there is this thing that I call infrastructure leakage. So another example that we used in the internal workshops with the teams. Recently we went through a workshop with an example of creating a basket. Exactly the same format, but guys were supposed to create a basket to which you put products, and basket calculates the total price of itself. And then the entire group in the first half a day went and implemented the domain model, and it worked brilliantly. And then in the second half of the day, they were supposed to add like infrastructure and persistence UI on top of that. And all of the guys like went properly and added like additional behavior or like additional responsibility with additional object. But one of the guys went and embodied an active record pattern. So he made his basket responsible for saving itself. And the wonderful thing started happening. His UI suite, or like a second phase, infrastructure phase, started passing, so it became green. But then his domain suite that was running for the first half a day started fading. And the reason why it started fading is because domain suddenly became aware of this persistence ongoing. So he damaged his domain code, his business logic, by introducing or leaking infrastructure concern in it. And he wouldn't notice it, he wouldn't know about it if he would just go end to end. But anyways, this is how we get to our green scenario in the end-to-end fashion, and actually 3 scenarios, because we also still have 2 domain scenarios running through domain. And we also have a couple of unit tests running behind the scene. So we have 1 interaction test running through end-to-end, we have 2 abstraction tests running through application service layer, and we have 7 unit tests. We ended up with a testing pyramid without actually thinking about testing pyramid, just through the process. So David West had this very brilliant quote that I love quoting again and again. Model the problem domain and the solution will take care of itself. What I want you to think about when you live in this session is, what if discussing the problem domain will take care of the model for you? Thank you very much.